In this lecture, we study the rectifiers with filters. Now, in the previous lectures, we studied the rectifiers and different types of rectifiers. So, in that, we are getting the pulsated DC. Means it is the output, rectifier output consisting of some AC component that is called the ripple. So, to remove this AC component and to get the pure DC at the output, we need the filter circuits. Now, for these filters, we are using the L and C components. Now, here, these are the different types of filters. One is inductor filter, capacitor filter. Means what? Here we are using inductor to filter the AC component, and only capacitor we are using the to remove the AC component in a capacitor filter. Similarly, LC filter or L section filter. We are using two components, L and C, and the shape it look like a L section. And we are using, and the fourth one is a CLC. So two capacitor and one inductor we are using, and the shape it look like a pi type. So that's why the shape it look like a pi. So that is a pi type filter. Now, why we are using L and C components means here this L and C reactance will depend on the frequency. So now if we take the inductive reactance, XL is equal to 2 pi FL, where the frequency is directly proportional to the inductive reactance. So means if the frequency is equal to 0, then it offers 0 reactance. 0 means for what? DC frequency is 0. So the meaning is capacitor will allow the DC component. It is not offering any reactance. So it is not opposing the DC component. Similarly, as the frequency increases, then the inductive reactance also increases. Means what? It try to oppose the AC component. AC component is having the frequency. So that's why if the frequency is increasing, then the inductive reactance also increases. With this, what we understood, so inductor passes the DC and opposes the AC. Now, if you see the capacitive reactance XC is equal to 1 divided by 2 pi FC. Now, here the capacitive reactance is indirectly proportional to the frequency. Now, if the frequency component is 0, then it offers the infinite resistance. Means what? 0 frequency is for what? DC. So, it blocks the DC. Capacitor doesn't allow DC component. It blocks the DC. Now, as the frequency increases, now here the capacitive reactance reduces. Means what? It offers a low reactance to the AC component. The meaning is what? It allows the AC component. So capacitor allows the AC, blocks the DC. Inductor allows the DC and blocks the AC. So based on this, now we are going to analyze the operation of these 4 filters. So now here first we will see the capacitor filter. Now here this is the rectifier, full wave rectifier circuit. Now 2 diodes are connected and 2 diodes cathodes are shorted together. Center point is grounded, and from this short to the ground, resistor is connected. RL is connected. Now to this resistor, one parallel capacitor is connected. If parallel capacitor is connected, then that is called the capacitor filter. One single capacitor connected in parallel with the load, then that is called the capacitor filter. Now already we have discussed that capacitor allows the AC component. So whatever the, now in this, whatever the AC component is there, that will be grounded and only DC will be available across the load. Now here AC is grounded and DC is available across the load. Now if you see this is the waveform. So here instead of getting the waveform like this after the capacitor, so almost it is looking like a straight line, but still some ripple is there, that is called the VR peak to peak. So this can be eliminated. Now to get the pure DC, we have to increase either the capacitor value or the resistor value. So if both the values are no, product of R and C is called the tau. So if the time period is more, if R value or C value or both the values are very high, then almost we get the straight line like this. So further, we get the pure DC if R and C values are very high. So this is about the capacitor. Now coming to the inductor. So already we discussed that inductor L value, L allows the DC and it blocks the AC. So now to the rectifier, we have to connect this inductor in series. Now here to the diode, now diodes are shorted. Now here need to, for this short, so need to connect the inductor in series and after that what? Load. So if this waveform is applied to the inductor in this AC and DC, both the components are present. So inductor will block the AC component and allows the DC. So DC will be available across the load. Now here you can see this is the input at the filter, and after the filter, after the inductor, so this we are going to almost, it is looking like a DC, but still it is not a pure DC. So to get the pure DC again, how much higher the inductor value we take, that much the straight line we get. So this is about the inductor filter. Now coming to the LC filter. So inductor is connected in series with the rectifier, and capacitor is connected in shunt with the resistor. So here inductor will block the AC. Now AC is blocked by the inductor over here, and it will allow the DC. If any AC component is present, still if any AC component is present, that AC is grounded through the capacitor, and DC is allowed at the load. So here we are going to get the pure DC at the output. So again, to remove the, now here, to remove the DC component, we have to increase the inductor value or capacitor value. This is the CLC filter. So one capacitor is connected in parallel. So this is the combination of, if you observe, this is a combination of simple C filter and L type filter. Now here, the shape it is looking like a L. That's why we are calling the L section filter. Now here the shape it is looking like a pi. Now this is one line and it is looking like a pi. So that's why it is a pi type filter. We are using CLC. 3 components we are using. That's why the name is CLC. Now if this is the output waveform of the rectifier. So from this AC is grounded by using the C1. And if any AC component is present, that will be blocked by the inductor. Now again the capacitor C2 also grounds the AC component and allows only DC at the load. So thereby almost we will get the pure DC at the output. So this is about the CLC filter. Now these are the 4 different types of filters.